Hey everyone, welcome to this video. Let's talk about LLM hallucinations. So, what are LLM hallucinations? Hallucinations occur when the LLM generates incorrect information. Hallucinations can be minor and somewhat trivial. For example, the LLM may say that a celebrity first got married in their late 20s when the celebrity had actually first gotten married at 22. But hallucinations can also be much more serious and be something that is completely made up. For example, the LLM may make up information about a certain disease or sickness. And a LLM hallucination that gives incorrect technical information, legal information, medical information, etc., can cause serious problems that will have serious consequences. So, this is important to learn about. So, an obvious question you may have is what leads to LLM hallucinations? So, remember that a LLM has next word prediction, which gives it general knowledge. So, if I say the name of the president during the American Civil War was blank, a good LLM with really good weights should say or predict the next words as Abraham Lincoln. While next word prediction has led to the LLM having the general knowledge that the name of the president during the American Civil War was Abraham Lincoln, the LLM does not actually know and understand the general knowledge that Abraham Lincoln was the name of the president. The LLM is predicting Abraham Lincoln as the next words in the sentence based on probability, not on factual accuracy and correctness. So, what do I mean by that? Well, let's pretend that if the massive amounts of text data that the LLM was trained on had enough text data that incorrectly said I, Kevin Nguyen, was the president during the American Civil War, the LLM may instead output based on its probabilities that I was the president during the American Civil War, which is obviously incorrect, right? So even if the model correctly guesses or predicts that the next words or the name of the president during the American Civil War was Abraham Lincoln, for all we know, behind the scenes or under the hood, it was very close to incorrectly saying Kevin Nguyen or me or I was the president because maybe there was a lot of incorrect text data during training that would say that. Next word prediction leads to the LLM having general knowledge, but this next word prediction is based on probability, not on factual accuracy and correctness. Therefore, hallucinations, when a LLM generates incorrect information, are caused by the LLM's next word prediction being based on probability, not on factual accuracy and correctness. Another way to think of this, the model does its best to have factually accurate and correct responses by using probabilities, but sometimes these probabilities lead to hallucinations when a LLM generates incorrect information. As we can see here, Kevin Nguyen has a 40% chance of being predicted as the president during the American Civil War. And hallucinations can look and sound correct. If the model does not have knowledge on something, it could try using the next most probable words that will look correct or sound correct, even if those next probable words would be incorrect. Let's give a concrete example. A LLM could be overwhelmingly trained on text data on animals that are domesticated pets, such as dogs and cats. The LLM could then hallucinate that elephants have fur and like to meow. Now, in this video, we will go over 5 ways to minimize hallucinations. And I have bolded the first one because this is the first thing we'll go over, which is during training by updating the model's weights. And we could have better model weights that hallucinate less if we have better training data and with reinforcement learning with human feedback, or RLHF. So, what do I mean by better training data? The LLM's knowledge comes from the massive amounts of text data used during training. If this text data contains flaws, the LLM will be more likely to hallucinate incorrect information. So, flaw number one, the text data has incorrect and or outdated information, right? Like maybe the massive amounts of text data that the LLM was trained on had enough text data that incorrectly said that Kevin Nguyen was the president during the American Civil War. What's a less obvious flaw? Well, the text data has missing information or lacks representation. So a LLM, as we just talked about, could be overwhelmingly trained on text data on animals that are domesticated pets like dogs and cats, and the LLM could hallucinate that elephants have fur and like to meow. And with reinforcement learning with human feedback, which we've gone over earlier in this course, so I'm not going to review it again, is that a good reward model could be able to catch hallucinations. So we give a prompt of, tell me some cool facts about elephants, and the assisted model generates a good response and a bad response. The correct response is, elephants are too big and cannot jump. But then it also hallucinates incorrect information with a response of, elephants have fur and like to meow. And if we have a good enough reward model, it would be able to see that this response is a hallucination and gives it a bad reward model score of -2, whereas the good response that elephants are too big and cannot jump gets a good reward model score. These scores are used to update the weights of the assistant model, and then once the assistant model hopefully has better weights, it will generate better responses and hallucinate less. Next up for minimizing hallucinations is during generation. One example is chain of verification, also called COV. And here is the reference to the paper I'll be talking about. And you can find this paper at this link if you are so inclined to read and are interested. But let's look at the diagram first to see what happens. You pass in a prompt or a query of list several common household pets. The model gives us 3 answers, 2 of which are good, 1 bad answer because elephants are not common household pets. And once we get this response from the model, we'll ask it verification questions. Are dogs common household pets? Yes. Are elephants common household pets? No. Are cats common household pets? Yes. Notice that the model contradicts itself. It said elephants are a common household pet, but then when you ask it a verification question, it suddenly contradicts itself. It says no. So now the final response, we will just use dogs and cats. So in chain of verification, or COV, or COVE, however you pronounce it, the model will do self-verification. The model will test its response with additional questions, and the model's final response can change from its answers to these additional questions. Next up is fit within the context window to minimize hallucinations. Now, what is the context window? The context window determines the LLM's short-term memory of its conversation with you. I'm sure that if you have interacted with an LLM, it will remember its conversation. It doesn't forget things all of a sudden. So an easy example, I tell the model I went to a pizza restaurant and I didn't like it very much. The model is empathetic and says, oh, okay, sorry about that. Sorry you had a bad experience. Then I say, I want you to write a constructive review. Now, the model doesn't go, what do you want to write a review about? Because the model has short-term memory. It remembers that I talked about a pizza restaurant, and because the model can remember that I previously talked about a pizza restaurant, it knows what I want to write a review for. So it goes, oh yeah, here's a constructive review for the pizza restaurant you went to last night, blah, 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 blah. So again, TLDR, context window equals memory. The context window size is in tokens, such as 10K tokens. If you have forgotten what tokens are, An oversimplification is that one token equals one word. So the context window size is in words, such as 10K words. It will include your responses, the model's responses, shared files, such as a PDF, etc. The LLM will remember everything in the context window, allowing it to generate better responses based on what has been discussed and shared in the past. And the LLM will forget everything outside of the context window. Let's go into more detail about forgetting things outside of the context window. If the model does not have enough knowledge on something, because that knowledge is outside of the context window, it could try using the next most probable words that will look correct, even if those next probable words would be incorrect. Here's a really intuitive example. You share a login error you are having with an application. You then give a long, detailed description of your computer's hardware, your browsing history, and your browser settings. So you start filling up that context window. When you finally ask, how do I fix this? Right? The LLM will have lost the original context, will have lost the context on the original login error, and will hallucinate a solution for a corrupted file error instead. Longer context windows can make the model have better responses, especially for longer text, and have less hallucinations. So why not make the context window as long as possible? Well, there's a catch. Longer context windows means more computation is needed because the model has to remember more text. All right, number 4 is external tool use, such as internet search and retrieval augmented generation, also called RAG. Internet search I find pretty intuitive. Similar to how you can do an internet search to look up something, like maybe you're curious about what year Abraham Lincoln was born, you could do an internet search, right? And you could also have the model do an internet search as well. The results of the internet search are put into the context window so the model can use it when generating a response. Having the model do an internet search is especially useful when a response needs the most up to date details on something that was not available during model training, such as who won the sports championship yesterday. That is very unlikely to be in the training data for the model if that championship was just yesterday, right? Next up for external tool use is retrieval augmented generation, or RAG. So, enhancing a model's knowledge with the results of an internet search so the model does not have to only use the knowledge contained in its weights from training, which could be outdated, such as who won the sports championship yesterday. It works, but what if the knowledge from the internet still isn't enough? For example, the knowledge has not been posted on the internet yet, or the knowledge that has been posted does not have a lot of information. What if we could enhance the model's knowledge with private data instead, like private articles in journals, or maybe guides, emails, internal chats from your business? After retrieving the required private data, the model can use this private data to enhance its knowledge and generate a better response. So, what do I mean by generate a better response? The model is less likely to hallucinate incorrect information since the private data should be factual, such as articles, journals, guides, emails, etc. So here's an example of what could happen during RAG. You ask questions like, what is my company's HR policy? Summarize the main findings on the newly discovered disease ABC123. These questions or prompts go to the context window. Then we retrieve that private data like articles, journals, guides, emails, etc., and feed that into the LLM. If your company's HR policy and information on disease ABC123 are not available on the internet and private data with the relevant information was not available, the LLM could hallucinate what it thinks would be the most likely HR policy based on its training data And the LLM could hallucinate what it thinks would be the most likely findings on disease ABC123 based on its training data. So maybe the training data contains data on disease ABC122, which may or may not be related at all to disease ABC123. And lastly, for the last main way to minimize hallucinations, let's talk about during prompting. So you can prompt the model to try and make it less likely to hallucinate incorrect information. For example, prompt the model to support its response, sharing the direct quotes and sources that it uses. Even if the model hallucinates the quote and source, it will at least allow you to better detect hallucinations. And you can directly tell the model not to make any assumptions or guesses. So before, you might say, summarize this financial report of the Kevin Awesome New Win Company into 5 key points. Instead, you could say, summarize this financial report of the Kevin Awesome New Win Company into 5 key points. For each key point, share a direct quote from the report as evidence. And for each key point, do not make any guesses or analysis. It has to be directly stated in the report. Now, there are other ways to minimize hallucinations that have not been mentioned in this video, and this video is already pretty long. I went with the main ways I found the easiest to understand and probably the most intuitive as well. And research into minimizing hallucinations is still ongoing. By the time you are watching this video, there may now be even better ways and improvements for minimizing hallucinations. So, to conclude this video off, I know we've gone over so much information, but if there's anything I want you to remember, it's this. It's easy to think that, oh, the LLM has actually knows and understands the knowledge that it has, but in reality, the LLM is predicting next words in the sentence based on probability, not on factual accuracy and correctness. And this in turn means that you can never be sure that LLM's responses are always factually accurate and correct. All right, that's it for this video. Thanks for watching. See you all in the next one.